Welcome back to another edition of TEC Tube. I'm your host, Ryan Hoger. We're going to dive into the Honeywell JADE controller for the advanced settings. We previously covered the basic setup for you earlier. You should watch that video first, but otherwise let's get started on the more advanced setup. I did want to finish up a little bit something on the basic setup screens that is a little bit more confusing and more advanced, right? So we have the fan low actuator position for minimum ventilation, and we have the fan high actuator position for minimum ventilation. And we talked about those in the previous video. We said that you can have different for CO2 and multi-speed fan and all that stuff. The hard part though is that all of these minimum positions are not in CFM and they're not in percent damper open. They are in voltage, and that confuses a lot of folks. So I want to cover it a little bit. So right now I'm showing you fan low actuator position 3.6 volts, right? And then the high one is 2.8 volts. So let's keep that in mind and we'll go through this here. All right, so for starters, the way this works is these actuators go from 2 to 10 volts DC. That means 2 volts means 0%. Close the damper. 10 volts means 100%. Open the damper wide open. So for starters, the middle of the range is not 5. I know that's annoying, right? 6 is the middle. That's 50%. 4 volts would be 25%, right? 8 volts would be 75%. And all these increments in between. So that's one thing we got to keep in mind. So let's say the minimum position, let's say for argument's sake, I want this thing to be 10%, right? So what voltage do I set that for? 2 volts would be closed, 4 volts would be 25, so I know it's somewhere in between there. The way it works is that from 2 to 10 volts, that's an 8 volt span, right? And I want to go 10%. 10% of 8 is 0.8. For those of you guys that love math. I know that gets kind of a little bit weird and a little bit annoying, right? But I want to set that thing for 0.8. But it's not 0.8, it's 0.8 above the minimum. So 2.8 volts, that's 10%. So our default high fan speed was 10%. 3.6%, or 3.6 volts, excuse me, is another 0.8 above that. Right? So 0.2 to get to 3, 0.8, so that's 20%. If I wanted 15%, that would be 3.2 volts. So instead of doing this math all the time, you may want to just make a chart like this once and never think about the math again, because most of us aren't here for the math fun, right? So 5%, that would be 2.4 volts. 25% would be 4.0. Right, like we said earlier. And you probably should never have more than 25% on a rooftop economizer, so it can handle that anyway. So if you kind of keep this in mind, or take a picture of that and save it, you don't have to really do this math ever again. But that's the way that works. The other piece of that is that people get a little messed up. Low needs to be a bigger number than high. People don't like that, obviously. The reason being is when I'm at low fan speed, I'm moving less air. So I have to open the damper up more to suck the same amount of CFM into the building. So as the fan speed slows down, I have to open the damper more. As the fan speed speeds up, I got to lower the damper down. So it always needs to stay inverted like that. Don't think it was wrong in the defaults or something. This number is always bigger, that number is always smaller for low and high speed fan. All right, now let's continue on with the real advanced settings. Now we're going to dive into the advanced settings, the actual advanced settings. So in the Honeywell controller and the JADE controller here, there's a separate menu for advanced, and the reason they do that is because generally speaking, you don't have to mess with that stuff. So for like 90%, 99% of the jobs, you never have to come into these screens, never think about it. But you should know how they work, because you may need to change it on a certain job, or you may need to tweak something to kind of band-aid a problem on a job or something like that. So we'll go through them. So I'm on set point screen right now. I'll scroll down to system setup and then advanced setup, and I will press the enter key. Now I'm in the advanced setup. The first one is mixed air temperature low limit. This is basically a mixed air temperature freeze stat. The default is 45 degrees. If it's below 45 degrees, it's going to assume there's a freeze condition, and it's going to go ahead and start closing that damper off. That's probably a pretty decent number. You can change that if you want to, but 45 is probably a pretty decent number. If you scroll down one, freeze position closed. So if I get below 45, close the damper. If you want to, you can have it go to the minimum when it's below 45. That doesn't make any sense to me because I should already be at the minimum. If it's that cold in the duct, I should already be at the minimum. But nonetheless, you can change that on here if you needed to. The CO2 sensor, I don't have one on the screen here because I don't have one wired in, but there's a 0 and a span, as you can see in the manual here. 0 to 2,000 parts per million is what almost every single commercial grade CO2 sensor runs at. So you would leave that alone in most applications. If you had something special you bought, then you might come in here and change that. Stage 3 delay. All right, so what that does is a normal economizer sequence. If it's a nice economizer day outside, stage 1 modulates the damper open. Stage 2 of the thermostat calling for cooling would turn on compressor number 1, and nothing would turn on compressor number 2. It could still operate on a non-economizer day, but on an economizer day, stage 1 is the damper, stage 2 is compressor 1. So nothing turns on compressor 2. What this will do is after 2 hours of stage 2 being called for, the economizer controller will assume stage 1 compressor is not going to ever get it done. It's broken, it's burnt out, something bad happened, and it's going to go ahead and energize the other compressor and bail these people out in the building. I like it to be at 2 hours. A lot of techs change it and make it 15 minutes. I don't like that. I get their logic. They want to satisfy the problem sooner, make the complaint never happen. Fine, I get that. I want the complaint to happen. I want the occupant to feel pain on this kind of day, which would happen in March or April, instead of it happening in July when they really do need 2 compressors simultaneously, and then they find out one of them is trashed. So I'd rather it happen earlier in the year, hence the 2-hour delay. Things get a little bit uncomfortable in the space. They call for service, and somebody can troubleshoot this early on. So I would leave it at 2 hours. I would not make that any faster. Shutdown damper position. By default, this damper will be closed. If you wire something to the shutdown input, like a duct smoke detector, if you want it to go open instead, you can do that. That would not be normal. Maybe you got a weird job. Maybe there's some kind of exhaust fume hoods or something, and the building occupant says, hey, when we turn on all these giant exhaust fume hoods, we need as much makeup air coming in the building as possible. We don't care about temperature. We don't care about freezing pipes. We need to purge air so people don't have a problem. You can do that and force the damper to go wide open if you want to. Not normal. Supply fan delay. You have a 2-speed fan, which we do in this case. What will happen is that when the thermostat calls for stage 1, we're operating the damper, but it only goes open, well, it goes open all the way, but the fan only goes so fast because we're on stage 1. When the thermostat calls for stage 2, the fan will ramp up to 100% capacity, and then you would turn the compressor on. What this will do is delay the compressor for 5 minutes by default and say, you know what? I got all that extra airflow, 33% more airflow. Let's just see if 33% more airflow of my cold outside air gets the job done. And if after 5 minutes it does not, I'll turn the compressor on. So I would leave that at 5 minutes, but you could tweak it if you ever needed to. And then you have the ability to calibrate all these sensors. So mixed air, discharge air, return air, whichever ones you have on there, you can calibrate them. You can go plus or minus 2.5 degrees. So let's say your mixed air temperature reading is 56 degrees on your handheld probe, but the one in the controller says it's 54. Like, oh, that's off by 2. You can come in here and go to mixed air, hit enter. You could change it and add those temperature degrees, whatever it needs to be. So I would sit here with my probe in my hand. This one's at 76. Let's say it's 76.7, right? And mine is actually 75.0. I would scroll down to 75.0 and I would hit enter to save that. And now this sensor is calibrated to match my sensor that I put in. Normally, these are thermistors. They're usually not needing to be calibrated. They tend to go bad or not bad. They don't tend to drift. So usually you're not messing with that, but you can. So it works the same way for mixed air, outside air, return air, discharge air. Humidity also works the same way, except it's plus or minus 10%. So if you have outside air humidity or return air humidity, you can calibrate those to match whatever you want as well. Previous video, we did all the configuration and basic setup. Here we did the more advanced setup. This thing is up and operational. Obviously, there's other screens. You can look at the status screen. You can use the checkout screens and stuff like that. But as far as getting things set up, you are operating at this point.